Hi guys, this is Gopika here. I hope that you watched my last video in which I had discussed about mathematical logic, and I had taught you how to identify a mathematical statement or a logical statement from normal sentences. And now in this video I'll be discussing about type of statements, that is simple and compound statement, and also about logical connectives. Okay, so without wasting time, let's get into the topic. Simple statements. Let's see the definition. A statement which cannot be split further into two or more statements is called a simple statement. Okay, now when you see the examples and after you see the definition of compound statements, you will get a better idea. Simple means it's just a plain statement and it can be split into two. Okay, so example, 2 is an even number. It's a statement. Now you cannot split into two into two or three statements. So this is just a simple statement. Okay. Now let's see what is compound statement. If a statement is a combination of two or more simple statements, then it is called a compound statement. Okay. So if you join two or more simple statements, then the resultant statement is a compound statement. Let's see an example. Example, 2 is an even number but not a composite number. Okay, now if you read the statement, I can split this into two statements, or you can observe that this statement is a combination of two statements. That is, first is 2 is an even number, and then statement is 2 is not a composite number. Now if you join these two, you will get the compound statement which is in the example. Okay. So compound statement means just combination of two or more simple statements. Okay. Now let's get into the next major topic, that is logical connectives. Logical connectives. I had told you in the last video itself, connectives means something that we use to combine two things. Okay. Logical connective means we are using those connectives to combine two logical statements. Let's see the definition. The words or phrases or symbols which are used to connect two statements so are called logical connectives or logical operators. Okay, so it can be a word, a phrase, or symbols. Now, most common logical connectives are binary. That means they include two arguments. That means they are using two statements. Okay. And also commonly negation is considered to be a unary connective. It includes only one argument. Now what is negation? It is an example of logical operator. And the speciality is that it is unary. Unary means it is using single argument. It is applied on a single statement. And when we say binary, those logical operators are applied on two statements. Okay, now when you see the examples, the fact will be more clear. See, these are the examples of logical connectives that we will deal in the basic level. Okay, so first one, if you see, let me take the pointer so that, yeah. The first one, if you see, negation, I have written over here that it is unary. That means it includes only, or it is applied, this logical operator is applied on a single statement. And symbolically we will refer it with a wave, and it means not. Not is the, we can say, the keyword which we use to negate a logical statement. Okay, that is when you apply negation on a statement, what you do is either you add not or you remove not. Now when you see the definition in detail, you will understand it. Okay, next logical operator is conjunction. Conjunction means combining. Again, this combines two statements, and the keyword is and. That means if you have two statements P and Q, then conjunction is P and Q. We just write it together. We combine it. That is, if two simple statements they are combining to a compound statement, and the connective used will be and, then such a statement will be we can say that it is a conjunction, and the symbolically we refer it like this. Okay. Next is disjunction. Disjunction means the keyword is or. If you have two statements, then P and Q, then we can write it as P or Q. Then we can say it is disjunction of two statements P and Q. Okay. And symbolically we will refer it with this. Okay. Conditional, biconditional. Conditional means the keyword is if, then. If P, then Q. If P and Q are two statements, then if I write it like this, if P happens, then Q happens. Then we can say that I have made it or applied conditional connective on that two statements. And biconditional means both the way the condition is applying. That means if P, then Q, and if Q, then P. And all together we will write it as if and only if. That is P, if and only if Q, or Q, if and only if P, both the ways. Now, I know that many of you will be confused when we see all this together, but one by one we will see it in details. So, let's first try to understand what negation is. Okay, negation of a statement. Now, how it is defined? For any given statement, P, there is another statement which is defined to be false when P is true and true when P is false is called negation of P. And it's denoted by, as I already told you, that symbolically we'll refer it as a wave and letter P. Okay, this small letter P is representing a statement over here. In the beginning or in the previous video, I already told you that we will denote statements using small letters, or we will name statement using small letters. That is why here we are used a small letter P. Now let's see example. P, now here this note is there. This you will understand after I complete this example. Okay. Now let statement P be 2 is even number. Now this is a true statement. Okay, that's why I have written T over it. It has truth value capital T. Now what will be negation of P? Negation of P is defined as false when P is true and true when P is false. So here P is true. Now I have to negate it so that the statement becomes false. Now how I will negate it? The keyword was not. Now here I will add not to the statement P, and I'll be able to negate P. So negation of P will be 2 is not an even number, and its truth value is obviously false. Now if once again I negate, if I try to negate this negation of P, that means applying negation on this negation P, then this not will get removed. I told you when you are doing when we are trying to negate a statement, the keyword is not. Either you remove not or you add not to negate the statement. Now when you have not in the statement, you remove it. When you don't have, you add it. So here you didn't have not, so you added to negate it. Now here you have not. Again, if you want to negate it, you will remove that not. Now if I remove that not, again I will get back P. See, if you notice, P and negation of negation P is same. 2 is even number, right? So this is what this note means. Negation of negation P is same as P. That means if I apply negation twice on a statement, then I'll get back the statement. Okay, I'll get the same statement back. Again, this has truth value T because it is same as statement P. Now, if you see the truth table is something which sum up all the cases. Okay, all possible cases. So if I write P and negation P, when P is true, negation P is false, and when P is false, negation P is true. These are the only two possible cases. Okay, especially when we are dealing with just. And now one more thing, we had mentioned that negation is a unary operator. Unary means if you see this operator, logical operator is applied on a single statement, right? Now when we talk about conjunction, you will come to know what we mean by single statement and double statements, whatever. Okay, so let's move on to the next logical connective. Conjunction. Conjunction means, now if two statements are combined using the connective and, then it is called as conjunction. So if P and Q are statements, then P and Q is conjunction. Now it is denoted as P and Q. So this symbol also we already saw in the tabular form in the beginning, okay, and read as P conjunction Q or P and Q. Now the combined statement, that is a resultant statement P and Q, is true only when both the statements P and Q are true. If both the statements are true, then their conjunction is also true. So the truth table will be, we will list all the possible cases where P and Q both are true. In one case P is true, Q is false. In other case P is false, Q is true, and in the last case both are false. So if we check, T and T is T. T and F is F. F and T is also F. F and F is also F. So only when both the statements have true, the resultant statement is true. And this is what happens in conjunction. Now, why this is so, why this condition is happening, we will come to know when we see examples. So let's do that. Okay, let's see the first example. Okay, P is 2 is even number and Q is 2 is prime. So P and Q is giving rise to 2 is even number and 2 is prime. So now in this conjunction, if you observe, P is a true statement because 2 is an even number is true, and Q is also a true statement, 2 is prime is true. So 2 is even number and 2 is prime. So this whole statement, that's the resultant statement, is also true. Now the problem with AND is it claims that both the statement to be true. Okay, now let's see some example in which one of the statement will be false and one of them will be true, and let's read it and understand what will happen with its truth value. Now here if you see, P I have kept again a truth statement same, and Q I changed to a false statement. 2 is composite. Okay, now this is a false statement. Now in this resultant statement, if you read, 2 is even number and 2 is composite. Now this AND means it claims both the statement to be true for the whole thing to be true. So again, this half part is creating problem. When one of the statement is false, the resultant statement will be false. Okay. So when both are true, the resultant statement is true. When one of them is true and one of them is false, the resultant statement is false. And when both are false, obviously the resultant statement is false. Okay. Now 2 is odd number and 2 is composite. Now this is a false statement. So I hope you got it, how we, the note that I had written in the previous slide regarding the conjunction operator, in which the truth table also we observed that true and true give rise to a true statement. One false and one true statement is giving rise to a false statement, and two false statements also give rise to a false statement. So only when, let's see the laser. Now, only when P and Q, both P as well as Q, both are true, P and Q, the resultant statement will be true. Okay. In all other cases, it will give you a false statement in the, means the resultant statement will be false. Okay. Now, I want you to understand the negation operator and the conjunction operator, and the rest three operators, logical operators or connectives, I will discuss in the next video. And please go through this video and ask any doubts in the comment section. Okay, if you have any doubts, please write in the comment section. I would love to reply. And thank you for listening to me. If you like my videos, please share it with your friends and subscribe my channel. And that's it. See you soon.